I think we can get started. You
Okay.
think? So,
Yeah.
welcome everybody. Thank you so much for joining us. Here is our third webinar. Today, Ciro, co-founder and CEO of Bauplan, is gonna present an end-to-end live demo using, of course, your beloved Bauplan and Claude Code. Ciro, I mean, stage is yours. Guys, if you want interact, feel free, use the chat, use the Q&A. I'm gonna do my best to interrupt Ciro and make sure that you know your question is gonna be addressed. Yeah.
In general, he's gonna do your best to interrupt me. I
Yeah.
love it. Okay. All right, so let's get started. We prepared some good materials. I think you have to allow me to share, Matt. Nice. Okay. Think you can all see my screen. So what we're going to do today is talk a little bit about how to do essentially data engineering using AI assistants. We're going to use Claude today specifically just because it's the one that we use the most at Bauplan internally. But all of what we're going to say is can be extended easily to whatever AI assistant you have in your daily life. The general story is, well, of course, AI assistants, especially in the past year, they became more and more ubiquitous in the way in which developers work, especially when it comes to software development. I think one thing that we consistently start seeing in the market, in our adopters and also in our daily conversation is that there's a lot of adoption that also came a little bit kind of bottom up, as in individual developers just adopted different coding agents, and now companies are kind of starting to um, you know standardize the practices, standardizes the way in which the agents are used in writing code and writing applications. And one big point that remains open is how much can we put inside of this workflow? It's only about writing code locally, or can we do more with cloud operations? And I think all that happened with MCP servers definitely point in the direction of making things more integrated with your AI assistant in general. So the main point about AI assistant compared to just where we were just a year ago, if you think about it, is the fact that they have more and more ability to manipulate the file system on your local machine, and so help you actually carry out tasks of software engineering, building entire projects from scratch. They can read your repo, they can generate the code, they can run commands, and then they revise based on the output that is printed in the terminal, or just streamed back and goes back into the context for the AI agent to implement a feedback loop. The loop, when it comes to writing code, works beautifully because most of the outcomes are very observable, and they're contained in local files in what happens in your terminal on your machine. And then the code is then checkpointed using just Git remotely. And this is kind of the workflow that everybody has with tools like Claude Code. It's very effective and extremely productive. The point is that this works beautifully because we have in this workflow, we check three main boxes. One is it is safe to try. You can run things, you can fail, and you can try again without breaking anything, because ultimately it works on your computer, and things will become consequential only when we decide deliberately to deploy. Plus, there's Git, so you can always, roll back and worst case scenario, you can undo any mistake your AI agent did. Two is structured feedbacks. So the fact that you can clearly tell the agent what happened in a machine-friendly way is the key for Claude Code to be able to iterate and to learn from what happened when it runs files and manipulates the local file system. And then fast iteration is very important because LLMs are very impressive, but sometimes it take a few minutes for the LLM to reason, to do everything. So they're not super fast, and it's important to keep the developer experience quick. So if it manipulates mostly text, and changes files, the iteration is fast enough for the developer to have like a very nice, tight feedback loop with the AI agent. So the AI agent becomes like really an assistant that helps going from zero to building an entire project in this assisted workflow. Now, the point that we're going to make today is in the spirit of bringing more and more operations inside of this workflow that is so effective and so productive, data remains a little bit of a problem. Working with data is different in this sense, mostly because, first of all, data um, tends to be done in data pipelines, and data pipelines are fragmented. Secondly, data are bulky, so it takes a longer time to do feedback loops because like sometimes like pipelines can take a long time to run. And third, there is no really a concept of it just works on my machine with data because like typically when you do data at scale, data will end up being somewhere in the cloud and other systems will depend on it. So basically doing data engineering with the very same workflow that we have for software engineering when it comes to AI agents is bottlenecked by the fact that we have several processing steps that happen in different places. They can be in different cloud runtimes, for instance. We see very often pipelines that are hybrid. Some portion of the pipeline is done on Spark, some portion is done in Snowflake, some portion is done with some custom runtime that runs in Orchestrator and so on. They each have like different execution environments and they're different places. The source data is diverse to say the least. Like there's many remote sources that come from a variety of applications, like different APIs, your application databases, your CRM, like external services, and so on. And the destination ultimately is some storage that is shared. So when you publish something in that shared storage, it's not like publishing just a file in your local file system. You're basically writing a table that now downstream consumers take for granted. They implicitly trust that new data. So that becomes like problematic because it often happens that when you write with an AI assistant, one of your top concerns is that the AI assistant can do something that is not exactly what you wanted, or like it can be a problem, it can be a mistake. You want it to roll back, you want to correct the AI assistant on the fly. So software engineering can really work freely because you work in isolation. Data engineering is much more ops heavy. And when you write or run a data pipeline, this runs like in shared storage, represents business state, and it involves several stateful systems that talk to each other. So this is really a problem for extending the same workflow that we have and we like when we do software engineering into data engineering. Plus, to be fair, I don't think like data systems, and this is really the point that makes Bauplan truly unique, is that most of legacy platforms, and so the data platforms, especially for analytics and OLAP that we're used to, are not really built for this workflow. They tend to be built for humans. So they have a lot of point and click templatized agent builders these days is a way in which you see agents being brought into the mix. Um, the code and the data change, but it's somewhere that is not necessarily on our machine. And iteration is very much like optimized for people clicking around, not agents writing code. So even when agents are brought into the mix, they tend to now appear in this way, where you have like an agent inside of console, you have a point and click interface, you templatize that, which is very different from what you do with Claude Code. Claude Code, you have your changes that and everything lives around the repo and lives around the code and lives around the possibility of implementing this feedback loop into the context with a very machine-friendly feedback. So Bauplan is built on the premise that this workflow with Claude Code is going to become like the way in which developers will develop across the board, not only in software engineering, but also in data engineering. And so we're going to see that the core innovation here is that code, data changes, and failures, they all live in the repo. So it's very IDE and very repo-centric, which is the way in which AI assistants work. And Bauplan is built on this concept of Git-for-Data, which is essentially a way to extend it to data the same abstractions that you have when you work with code. So when you run and you do changes on your data, they happen on isolated data branches, and the publishes the publication of changes, they happen as atomic merges that can be rolled back. So it's very much about like making that same workflow that is software engineering friendly the same when it comes to data. The execution in the data, of course, live in the cloud because we're doing data at scale, but your workflow will look a lot like what you do normally when you develop a local project with your Claude Code. Today, we're going to show you how this works in practice, and we're going to go from zero, as in like I have some data somewhere, to building a pipeline and exploring the data, exposing the data, and do something new with it in the cloud, in a lakehouse, effectively. So we're going to do that on some Iceberg tables that live somewhere in the cloud in an S3 bucket. We're going to talk a lot about like skills specifically. I know that so Bauplan also published like an MCP server like everybody else. Like last year, there was been a long discussion about MCP. Skills are a bit newer way of doing things, and they're slightly different. So because it's so new, let me say a couple of things there. One is, generally speaking, an MCP server is a way of standardizing the way in which your agent will talk with a bunch of tools and interact with external systems and get the data in and out the feedback loop that is required for the AI agent to do his job. The skills are more a way to templatize some more complex workflows. The main difference is that they live really next to your code. So basically are just markdown files that standardize some more complex workflows that use the tools. So in a normal setup, skills will live alongside the MCP server. In the case of Bauplan, the MCP server become a little bit of an optional tool because as we're going to see, the APIs and the surface that the AI agent manipulates is so tight and so simple that we don't quite need necessarily a server to handle that. The agent can just bash his way through all the commands using CLI APIs to do the entire workflow. So we're super happy to dive deep into the MCP server for everybody who's interested in that because it's a very popular standard that is catching up. But just for you to know, like in this demo, we're going to do things in a way that is even simpler than using an MCP server and basically just have a bunch of markdown files directly in the repo. So without further ado, I think we can definitely go and see something more interesting, that is seeing how this works in practice. So the first thing I'm going to do is, well, this is, as you can see, just like a very simple repository. We're going to have like a ClaudeMD file. The ClaudeMD file has some high-level indications for Claude to work with Bauplan specifically. And then we're going to have some skills. Then the skills templatize some things that we do specifically when we do data engineering and when we build data pipelines in the cloud. And we're going to go through the skills like with more detail while we develop. The first thing I'm going to do is just very simply fire up my Claude and have Claude now living next to my skills and have access, as you can see, we have access to our skills as expected. Okay, so let's start with a prompt that I prepared here. It's very simple, and it's this. Hey, I have some data in an S3 bucket. I want to import the data in a lakehouse as an Iceberg table so I can run queries and pipelines in it. So we're going to basically take some new data and we're going to put it into our lakehouse so we can work. The system starts using this skill that is called WAP. WAP is an acronym that stands for Write-Audit-Publish. What does that mean? So as you can see here, this is our skill. The first thing that the system will ask us is where the data come from and what we want to do with it. Give me one sec. So the data comes from here. So the first thing we do is going to do, after successful ingestion, we're going to inspect. And if the suggestion fail, we're going to keep. I'll tell you in a second what this means. Basically,
Ciro,
yes.
I think we have one first question.
Go ahead.
And so, say, what do you use a small model for this?
A small model, as in like haiku, for instance. It's not terribly problematic. It depends on what you want to do, but like my experience with haiku is that is actual like I can do most of the things that I do with Sonnet with haiku as well. If you're referring to like a small model, as in like this is a model that you host yourself and it's like really, really small, that's a different story. But generally speaking, I don't think that for most of the things that we're going to see, the bottleneck is intelligence. The bottleneck in data engineering and AI assistance today is the platforms, is not really the model. Um, going
Me?
back to, yeah, go ahead.
No, please, please.
Going back to the main flow, we're going to say that this data here is some data that I have on an S3 bucket somewhere, and I want this data now to be called, let's call it Instagram table name. We're going to call this table Instagram synth data. This is a data set that I just like downloaded from Kaggle, nothing like particularly complicated. But we're basically telling now the system that here's where the data lives, and we want this data to become like an Iceberg table, and we want to be able to work on this data. The system is using this skill that we prepared here that is called WAP. The skill here tells that the import should use the abstraction of the branches. The branches means that instead of importing this data directly into the same data lake and in the same lakehouse that other systems are reading from, it's going to create a branch in which is an isolated sandbox. And we're going to do our experimentations in that sandbox. And only when we're ready, we're gonna merge that branch and we're gonna make that data available to any other downstream consumer that we have in production. Okay. Um, the concept of using Git-for-Data here is, as I was mentioning in the beginning, very much around like it's very much about making the same, giving you the same experience that you have when you normally run code. This time, like doing something with your data instead. So what the system is doing probably is creating a new file. Here we go. That we can inspect now. And this file that is called Write-Audit-Publish we just like write Python and use Bauplan as APIs to do what we just tell them to do. So, okay, so this is done. I'm going to show you what this means. If we go on our UI, so the terminal and the code like works very well for the AI agent. Sometimes you want to have a UI because you're a human. Here you can see like the concept of branches. So the main branch here is basically a collection of tables, and each of these tables are tables that you can see, you can preview, you can query if you want. It very much like looks like any other data lakehouse that you've seen in your life. But we do have like special branches that are different branches of this lake house. So different branches will contain different tables or different versions of those tables. We go here, we know that we just created a new branch. I mean, Claude, created this new branch. Go here. So when we swap to this one, and we see what are the history of the commits, which is what happened on this branch, we have an import Iceberg table right here, which is what we just did. So it means that we just created a new table. That we can inspect. We can do a preview. And of course, if we want, we can very simply now run a query against it. This table, like this data was in a tree, is now an Iceberg table. And so it has all the advantages and the guarantees of having an Iceberg table. So effectively, we can just like query and work with this data. The important thing here is that if I go back into my main branch right here, and I run this query again, this is going to fail. because the table that we just created exists in our data branch, but it does not exist in main. It hasn't been published yet. So in fact, cannot be found. Okay? And this is how we sandbox the work of the agent so that we can work safely with our AI assistant without worrying too much about what happens to production. Okay? So inspecting through the UI is nice, but because we now dispose of infinite intelligence, we can actually ask Claude to help us understanding this data, for instance. It's like, you can write a short report with a description of the data. I want some general stats and I want the AI agent to flag potential problems. Okay. When we prompt Claude to do this, now we're going to like what happens under the hood is that it goes on a reference. It takes like all the CLI commands. And the beauty of Bauplan is that your entire workflow as a data engineer is squeezed in a handful of concepts that are exposed as CLI commands. And it's going to just like run a bunch of queries basically to understand what is going on. We expand, for instance, here, and we see what it's doing under the hood. It's running like bash commands like Bauplan query and then a certain query to understand what is happening. And is doing this against a specific branch, which is the one that we just created, right? So if we go back to our terminal, here we go. We have our quick data report that is correct. There's like, these are the rows, the columns, this description of the data, some key statistics. We have a data quality assessment, an observation of what the data looks like and what are the problems that we might have. Like in this case, this data is synthetic and rightfully Claude picks it up and tells us, well, this data is synthetic, so you should be careful about using that as a production ready data set.
Ciro, we have a
Yes.
question that can be
Yep.
helpful for everybody. So the question is basically saying, I was just recently introduced to Bauplan. If I understand correctly, part of a platform is also a compute layer.
That's
If,
correct.
if so, does it support distributed runtimes, and how does it fare with volumes of data that are larger, that are on the larger side of the spectrum?
Yes. So Bauplan is absolutely a runtime. The way in which things are run, I'll show you in a second when we run a pipeline, but the way things are run are also very friendly to AI assistant and isolated runtime that sandboxes steps of computation so that we make sure that, again, like every mistake or every problem is very much like contained. So we've reduced the potential ramifications of using AI assistance in the flow. Right now is a single node application. So in production, we have workflows as big as a terabyte. For anything that is larger than that, what we typically see is workflows that are hybrid, where Bauplan is used for certain nodes, and distributed engines like Spark or Trino are used for larger nodes. We have in our roadmap to build like extended to distributed, but as of for now, there's a limitation in size. You typically want to use Bauplan for anything that is below a terabyte. You're muted, my man.
I would say, so thank you.
Yes.
Thanks for the question. We have another question from our good friend Elvis that says, when other teams want to query the data, I'm guessing they'll go through some catalog. So once you have merged your branch to main, does Bauplan register the new tables within the catalog?
Yes. So as a matter of fact, the catalog is not only main. This that you see here is the entire catalog, and the catalog encompasses all the different branches. So these are all branches that are like real versions of the catalog. So when you merge, you publish into the main branch of the catalog, but every single Iceberg table that you query, create, drop, recreate, or run pipelines on in a development branch is also part of your catalog. It's just part of a sandbox. It's just part of a branch.
So we have two questions. One is critical, and I keep it for later. Let's
Okay.
get start with a good. We one that is basically say, okay, it's pretty much very cool what you did. So you have abstracted data engineering pipeline and software engineering pipeline. However, a data engineering pipeline always will have dev, QA, and prod, and code is really the only variable along these config parameters as a YAML file. I wonder if this makes things simpler or more complex.
A data pipeline in production today with Bauplan looks like you can of course implement like your conventions where you have like your QA, your dev, and your prod. What will happen with your data pipelines in Bauplan is that it's going to look a little bit more like just what you do with your code. So it very much depends on what is your CI/CD process and how you handle that. Some clients of ours have like very distinct, environments and distinct practices to publish against those environments. Others use like the branches in a more free form, and so you have like just like different variations that live as branches and one CI/CD pipeline to publish against main.
Okay, one more question, and then I'll let you continue the demo.
Sure.
The critical one. So, do you have a dark mode for the UI of yours?
We do not, but we should. No, wait.
We
Like
do we do have.
that's not true. Like we do have like an
Ah,
automatic dark mode, but
that works pretty well.
you cannot click it. Like you cannot do it
That's
yourself. So like okay,
fair,
so
fair
okay,
enough.
yeah.
Fair
So
enough.
it goes
Go ahead.
automatically. So yes, but that's fine.
Go
Okay.
go ahead.
Like I want to also say that like this might be not a very popular opinion, but like we're kind of a very kind of like uh not very dark company in general. Like our website is not super dark, our UI is not super dark. So and that might be because like I honestly don't see very well. And that's my problem. Okay, so now that we have our new pipeline, sorry, now that we have our new uh, table, what we can do is we can merge it as we using the terminal this time. So this I'm going to do manually just because like it's a merge operation, so it's the kind of stuff you can automate this with with an AI agent as well. But this is typically where you have like CI/CD steps in place. So I'm going to do it just manually for the sake of the demo. But basically, what we're going to do here is do Bauplan branch and then merge, and then we're going to say, okay, so now if everything went correctly, I should go back into my um, main UI. And if I run this query now against main, I find my table. So yay, we just published an Iceberg table in a Write-Audit-Publish workflow using Claude. I have my table now, so maybe I want to do something more interesting now and do an analytics pipeline. So one thing we're going to do, given that this data is about social media, I'm going to use this other prompt and it's going to say, hey, let's build a pipeline for the marketing team who needs to understand engagement metrics for social media. Let's say that we want to build a pipeline that calculates different user segments by engagement level. Do the entire pipeline as Python and use polars because it's better performance. Um, we can do 3 tiers. Should the pipeline include calculated engagement metrics? Um, sure. How should the apple be materialized? Replace, definitely. Submit answers. Okay, so now what is going to happen is that we're going to use a different skill. This skill right here, which says create a new pipeline. I'm going to spend just a minute to tell you what is happening in terms of runtime while our friend is doing this. So one sec. Got it. Let me get more details. When I get something else also for Instagram. Threshold base sounds good. Can tell what we want to do. which needs to contribute to daily active minutes. Many engagement tiers we want. We want 3 tiers. And then we also adjusted. Okay. These are all inferences that the model is doing for us. Like this is basically Claude asking us, what do we want for this pipeline in our data pipeline? Is what I was mentioning before. Like the bottleneck right now is not the intelligence. Like the model will be able to analyze the data and will be able to come up with good ideas. The bottleneck in data engineering today is mostly the platforms and how they are designed to talk to something like Claude Code in this particular workflow. What the model is doing now is creating a pipeline. So creating a pipeline follows this skill right here, which of course which gives like an entire definition of what is a pipeline. A pipeline is a DAG, how you should organize this, what is required, what not, and so on. But I want to just like do one thing specifically, that is like spend just a second on what is the computational unit of a pipeline in Bauplan. A pipeline in Bauplan looks like a bunch of SQL queries in a very kind of like dbt-esque way, if you want, or the preferred way to do this is actually a bunch of Python functions. So a pipeline is just a bunch of functions like the one that you see here, chained together. Each one of these functions is one step of the computation. There's a few things here that make this a bit special. There's the decorators. They basically tell that this function right here is a Bauplan model, so a step of a pipeline, and that for this specific function, you're going to use certain dependencies inside of the function, like in this case, polars. But this can be pandas, can be DuckDB, can be scikit-learn, can be NumPy, like anything you can install in a Python function. We abstract away the entire infrastructure. So everything is declared in code so Claude can know what is happening. And then inside of the function, you can just like do whatever you want. This is the output. So when you run this in the cloud, it's very fast because the runtime is optimized to do a bunch of like push downs against S3 and like work a little bit like, an SQL engine, but in Python.
Sure.
So, yep.
We have a question related to materialization strategies.
Yes.
So, consumption tables in general in production are persistent. For example, you do not often want to replace them as part of your code promotion, or in this case, merging. Is there a way where you exclude the table deployment?
So, first of all, if you don't want to replace the entire table and you have like a table where you have data that continuously flow in, you just change this from replace to append. And what you will have is just like appending progressively new rows to an existing table, which is what typically you do when you ingest data in production. You don't have to materialize everything. There's a bunch of tables you can just like skip and you can run it in memory if you want. Like this is actually an optional parameter. So ultimately you want to materialize something because that's the reason why you're running a pipeline. But it happens very often you have a complicated pipelines and sometimes like the intermediate steps, you don't necessarily need to persist them in S3. So yeah, that's it. But yeah, but you can definitely, you don't have to replace a table. Like with large tables, this becomes like very impractical, of course. It appears that we're done. So we have a new pipeline. We can look at the new pipeline in our code. So we created a Bauplan project. The pipelines are by convention in a file that is called model, and it follows the syntax that I was mentioning before, right? So these are Bauplan model. These are the columns. This is the infrastructure for our container. These are the columns that are read from S3. And we have our code that tells us like, okay, this is our, step in the pipeline. This is the output that we have. So if we did this correctly, we should have a new table that is called Bauplan user engagement segment in a new branch, ideally. Sorry. Oh, there you go. Okay. So one thing that I can do is just like check what are the new branches here. Bauplan branch. Yes. So yes, so we created a new branch, engagement segmentation. Oh, we are already in this branch. Okay. So
Chiro,
Yep.
just for you to know, we have like more or less 5 more minutes and at the
Hmm.
very least a couple of questions that we might want to address. So
Beautiful.
just for you to know.
Yeah, I mean, this is basically done. So this is like how you publish like your final table against, like your new branch. New branch here will be, sorry, engagement segmentation. So we can do, and our table should be this one right here that we see. Okay. So the good thing about having like everything as code and so repo centric is that one thing that we see very often with our customers is that once you have to explore this data or give this data to somebody else, you can usually do something like, for instance, Streamlit, which is like a pretty beautiful package you can use to do front-end applications directly in Python. So an idea could be just like then once you have something like this in the very same repo, ask Claude to do, hey, can you build a Streamlit app for the marketing team so they can explore this inside? Like now everything will live in the repository right away. And you can have like your final deliverable for not for the data engineer, but sometimes it's for the analyst or for the business persona that wants to look to the analytics. We integrate with BI tools, like more traditional BI tools as well. But this is like a very kind of like AI friendly way of doing things. Is literally just like vibe coding an application that you can use to visualize your data on the spot, which is a pretty cool way of doing this. If you like given the options, right? So yeah, we can do this.
Awesome. So let's move to the questions because we have a handful of
Mhm.
them and not that much time. I'm gonna copy and paste here to the chat a very interesting one that we just got. And so what is your instinct or on proactively or reactively getting data context for an agent? For example, should we keep a file system available to the agent that has the schema of each production table or give the agent tools to retrieve when needed? For example, some data warehouse from the lake or stuff like that.
Mhm.
And then there is another example if you want it, but
I mean, the design that we chose is definitely using the tool. The design that we chose is that your data, because like the data is always remote, like the data is always somewhere else, and it changes. This is the thing that makes data hard, is that it changes constantly, and it changes constantly because external systems modify that. So you want your agent to be able to retrieve all that information that goes directly into the context in a way that is friendly for a machine that needs that data in the context from a tool. So it's always fresh, and it's always the last version.
okay, let's move to a Hoyt question that is also related to context. It
Mhm.
said, do you have any personal preferences in regarding to organizing your context engineering? Do you stay in one long closed session to do multiple pipelines, or do you break those on into multiple sessions threads with the AI?
I personally tend to have a session per pipeline just because like it's more efficient and it keeps like the context cleaner. And I am a great fan of skills versus MCP because it is more context savvy. So you don't have to put like so much stuff in context. So it's a bit more it's a bit less expensive.
Okay, we have two more like general questions.
Hmm.
Let's start with a phenomenal one that I'm gonna type to the chat here for everybody. I'm gonna also rephrase that a little bit. How can I convince managers and stakeholders to stop using traditional platforms like Azure Synapse and use platform like Bauplan? Because all the objection that I keep hearing is just yeah, but that's Microsoft. Da 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 da.
Well, that's a variation on the nobody gets fired for choosing
So,
IBM.
correct.
Yes, that's correct. It seriously depends on what is the need of your organization. If your organization has the need of bringing AI tools in the mix in a way that is native to those tools that are becoming the de facto standard, like Claude Code or Cursor or Augment or Cognition and so on, there's not a lot you can do on a traditional platform. You will end up having agents that are provided by Microsoft, and that is typically okay for less technical stakeholder, but for engineering, I think that's just not an AI native way of doing things. So I guess it really boils down to how important it is for your organization to not be left behind in the adoption of tools like Claude Code, for instance, and not limiting that adoption to only one workflow, but to a larger range of workflows so that you include also data engineering and data analytics.
Awesome. Very last question that I personally find very interesting. It's more like a general and broad
In the meantime,
question.
I want to see what Claude did. So yes, go ahead.
So
Just out of
the
curiosity.
question is, how do you see data engineering and science and software roles converging with tool like Bauplan? Are you noticing a converge of roles or a conversion of processes or both?
So that's a very good question. Data engineering, I think like data engineering has been tied to the tooling a bit too much. My experience with data engineering is that a good data engineer is a person who understands how to deal with data. And then the tooling kind of like comes after. So I think that expertise and that way of thinking is not going away. That's important for your organization. It's important to have people that really understand data and how to work with it. I think what will go away is the sharp distinction between the tool chain. And so you can be a bit more fluid if you want. Like there will be software and product people who have a more data-driven mentality, just like normally be able to take on some of the work of data engineers and vice versa. Um, Historically has been very different to have like communication with these two roles because like the data platform team works in a very, very different way with very different tools from the rest of the engineering team. And I think that very frankly, it's an historical byproduct. It's not, I'm not saying that everybody's stupid. Like it's definitely an historical byproduct, but I think that right now that model slows down organizations significantly.
Um, I would say that we can wrap it up here. I mean, guys, I share with everybody mine and Chiro's LinkedIn contact. Feel free, to connect with us, to send us additional questions. We're more than happy, to also sit down and have a chat with anybody who wants to know more. Again, thank you so much for joining us today, and let's be in touch.
One sec. I still want to do one thing before closing.
Or you can stay here with Chiro where he keeps playing with
I
his
want to see what it
pie
did. I want to
chart.
see what it did. Oh, he didn't do the streamlit up right.
You
Claude.
see?
Haha. Oh, but the beauty
You
of
see?
this is that if it doesn't work, we
So
could just tell him.
reach out
Right.
to us that we're gonna try to have a better stream lit up next time.
I
Thank you
mean,
so
that's an
much.
Anthropic side, honestly. Like that's
Yeah.
not us. That's Anthropic.
Yeah. And such say maybe with a larger model next time. Maybe. Why not? Why
It
not?
is actually Sonnet, so you know.
Thank you guys. Thank you so
Thank you for
much.
coming.
Also keep in mind next webinar in 3 weeks or so. Okay. Bye guys.
I'm good. Bye.
Bye.